They are also known as alkyl halides. And aryl halides. So what do you mean by this? And what is the general representation? You have alkane, right? And suppose alkane you know is methane, ethane, propane. This is an alkane. You remove one H and you put a halogen. So I'm writing minus H and plus X. Halogen is, it can be fluorine, chlorine, bromine, or iodine. X is the general way to represent all four of them. Okay. So it becomes CH3X. I need to remove one H so that the bonds remain same and the valency is satisfied. So this alkane, whatever is derived from alkane, are known as alkyl halide. Got it? So
Yes, sir.
Jaslyn, is it clear? Jaslyn, am I audible?
Yes, sir, it's clear.
Okay. So suppose if you are taking ethane and if you remove H and put Br, let's say. So this is the bromo derivative. Okay, mono-bromo derivative of ethane. What is the IUPAC name? Can you tell me? So Ibrahim and Jaslyn, can you try?
Yes, sir. It will be one bromoethane, one bromoethane or bromoethane.
Hmm. So Jaslyn, why it is one?
Because of the position of bromide.
Yeah, actually you are going to start the numbering from the end, which gives the lowest number. Okay, I will 1 and 2. Okay, so this is one bromoethane. Got it?
Yes, sir.
So you can have uh, two bromoethane, three. You can have two bromopropane. Okay. So good evening, Zainab. Am I audible?
Yes, sir.
So which chapter is going on in your school?
Chemical kinetics.
Chemical kinetics. Okay, so just what we decided is that we can initially start, because next chapter will be haloalkane and haloarenes. Okay, so we will cover this and then we will start the kinetics. Okay, I hope it is fine, right?
So next week we'll be having exams starting like in few weeks.
Yeah. I will take care of that, and whatever the chapters are there that we can cover, Ibrahim, Jaslyn, and Zainab, we can take extra class for your exam. Don't worry about it. Okay.
Okay,
Yes.
sir.
There. So just be relaxed. Okay, we will have the class. Just coordinate with the management, and we can have the classes fine tuned. So don't worry about it. Okay.
Yes.
So just because next chapter I think will be this only haloalkane, because all of them Ibrahim and Jasleen completed, so we can complete this and then we can move on to this kinetic solution. Okay, whatever we are having. Okay, and today also I will talk to the management to have your classes adjusted. Okay, according to the kinetics also. Right. So I was talking about this haloalkane and haloarene. So what are alkyl halide? I was discussing that. So you start with an alkane, and Jasleen and Ibrahim told that you remove that H and put some halogen. Halogen can be it is general way to represent halogen is by letter X. It could be fluoro, chloro, bromo, or iodine. Okay, is that clear? So, for example, if you start with ethane and put one bromine, and this is one bromoethane. Got it? So, and if you start and this with propane, this is propane. Got it? And don't worry about the names, right? I'm going to explain it in detail, so you don't have to worry anything, and just let me know whatever is not clear. That is your duty. Okay. So suppose if I want to put one bromine, there are 3 carbon atom in the propane. Where can I put one bromine? One bromine atom. What all places are there on this propane where I can put where I can attach one bromine? How many different places?
Three places.
There are 3 carbon atoms. Okay.
Yeah, so 3 places. We'll have to
And
remove one hydrogen for each carbon, for each bromine. No, on each carbon, we have to remove one hydrogen.
yeah, we have to remove hydrogen otherwise, because carbon can make always remember 4 bonds only.
Yeah.
Zainab and Jasleen, is it clear? So if I am putting the bromine, I need to remove one, replace the hydrogen by bromine. And there are 3 carbon atoms. So as per what Ibrahim said, I will do this. Got it? I can do this. Jasleen, is it clear or not? And I can put on the extreme rightmost end. Is it clear? Zainab and Jasleen.
Yes, sir.
Okay. So are these all 3 of them different or same? So what is the name of this first molecule? Yeah. First molecule, I will do the numbering from the side which gives lowest number to the carbon atom on which the group is attached. Okay, I will do the numbering, Zainab, from this side. So Zainab, tell me what is the IUPAC name of this? Just try it little bit.
1 bromo.
1 bromo propane. Very good. This is 3 carbon is propane. Okay. And Jasleen, tell me what is the name of this compound?
2 bromopropane.
Yeah, 2 bromopropane, because I will do the numbering either from this side or this side. It is one and the same thing. So 2 bromopropane. And Zainab, tell me what is the name of this? The last one. 3 bromopropane. Okay. Because the bromine is attached on the rightmost end, should I start my numbering from that side, or should I start from the side which is immediately giving the lowest number to the bromine? Just think of it little bit. Everybody, all 3 of you.
So the one which is the longest chain, but the bromine gets the lowest number.
Exactly. That is called lowest locant rule. Okay. How do I eat my food? I eat my food like this. I don't eat it like this. Got it? So I follow the shortest path. Got it? Now you also do it like this. You don't bring your hand from back side of your head. Okay, that will be the long path. Got it? So in the same way, this numbering we should change, because this is giving a larger number, and we will do the numbering from this side, 1, 2, and 3. Are you getting my point or not? All three of you, Zainab, Ibrahim,
Yes, sir.
Yes,
Yes.
sir.
Teslin. Okay, so both are same. This is also 1 bromo. This is not 3 bromo propane. No, this is 1 bromo propane. Got it? So this is one thing. Is it clear? Before joining, before making, instead of making all this, I can do the planning prior to starting the drawing of the structure. Look, this is a symmetrical molecule, and this side are same. Are you getting me? This is also methyl, this is also methyl, right? So either bromine on this side or this side, it is going to be same, because if you flip it like this, it is going to be same. So 1 bromo and 3 bromo are just identical. Got it? And there is one middle carbon that will be different. Okay, so that will be 2 bromo. So 1 bromopropane and 2 bromopropane. There are 2 monobromo derivatives of. Okay, so this I will write as same. I will cut it. Okay, now, because it is matching with the first one. So propane has 2 monobromo derivatives. And the IUPAC naming also we understood clearly. Got it?
Yes.
Yes, sir.
So this is a common question. And how do you classify alkyl halide? Okay, or haloalkenes? It is one and the same thing. Haloalkenes or alkyl halides means halogen on alkane. Got it?
Yes, sir.
Is it clear? So these are haloalkenes, and propane has 2 monobromo derivatives. Got it? How you can analyze 2 monobromo derivative means if you replace one hydrogen by one Br, Jaslin, you are going to get 2 compound, 2 different type of compounds. Got it?
Yes, sir.
And this is primary carbon. This is primary. What do you mean by primary? Zainab, Jaslin, Ibrahim.
First carbon.
Yeah, related to carbon, carbon connected to one carbon is primary. Okay, because this is on the extreme end. So this carbon on which the Br is there is connected to just one carbon. Got it? And what kind of alkyl halide or haloalkane is this? Is this primary, secondary, or tertiary?
Secondary.
Yeah, secondary. Is that clear?
Yes.
And what do you mean by tertiary?
Bromine attached to the third carbon.
Yeah, bromine attached to a carbon which is connected to 3 different carbon. That is tertiary. Okay. Is that clear?
Yes.
If I,
Yes, sir.
this is an example of tertiary haloalkane. This is tertiary carbon. What type of carbon? Tertiary, because it is connected to 3 carbon atoms. Got it? That's why it is tertiary. And this is an example of iodoalkane because the halogen is iodine, right? So can we try name to name this to assign a IUPAC name to this compound? Just try it, all three of you, quickly. So select the longest chain of the carbon, longest continuous carbon chain. Okay. So 1, 2, 3. Either continuous carbon chain, either you move it this way or from top to bottom. You can have just total carbon are 4, but when you move from one end to another end, you have just 3 carbon atom. I hope this is clear. So first, I need to select the longest chain. Ibrahim, Jaslin, Zainab. Is that clear?
Yes.
Yes, sir.
Okay. I should do the numbering from one end to another end of that longest chain. And it should start from the end, which gives smaller number to the carbon atom carrying the iodine or side chain. So either you start from 1, 2, and 3, or you can do it in this way also. You can assign this 1, 2, and 3. This is one and the same thing because the iodine is coming on the middle carbon. Got it? So just we can try to name this compound. Just first of all, tell me what is the name of the parent chain. Parent is a main chain. Yeah, Zainab. What is the name of the parent chain? 3 carbon.
Propane.
Propane. Very good. And Ibrahim, you tell me what are the numbers? What are the number for the position where the side groups are attached?
2 methyl, 2
Yeah.
iodopropene, I think.
2
No, 2
iodopropane.
methyl. Yeah, 2 methyl, 2 iodopropene.
Okay. And Jaslyn, tell me, should I write 2 iodo first or should I write 2 methyl first?
Methyl.
Which is coming before in alphabetical sequence? Is the I coming before M or M coming before I? So what
Sorry.
should I write?
Sorry, line, can you repeat?
Yeah, these groups are written in alphabetical sequence.
Yes, sir.
Okay, so what should I write? Should I write 2 methyl and then 2 iodo, or should I write 2 iodo and then 2 methyl?
2 iodotyl.
Is that clear to all three of you? Zainab, Ibrahim, and Jasmine.
Yes, sir. Yes.
Yes, sir.
So these are known as prefixes. They are written in alphabetical sequence. Irrespective of their numbers, they are written in alphabetical sequence. Got it?
Yes.
Clear? What do you mean by aryl halides?
Benzene rings which are attached to a
Yeah.
halogen.
Exactly, ring, but there are many types of rings in organic chemistry. Okay?
Benzene rings, yeah?
Yeah, benzene. Or the
Yeah.
full form is aromatic.
Yeah, arom.
The full form is aromatic halides. That's why the aryl group, or it is also known as phenyl group. Aromatic halide means if I try to decipher it in detail, it is halide halide is FCl, Br or I connected to an aromatic ring, like the most famous aromatic ring is like benzene or phenyl. Is it clear to all three of you?
Yes, sir.
So benzene is, so this is not benzene, first of all. This is alkyl halide only, alkane, cycloalkane. Benzene is this one. It is a cyclic ring xenon with 3 alternate double bonds. Or if I want to write it in detail, it is like this. CH, double bond CH, single bond CH. Okay. But now you will not write this kind because it is a time consuming process. But it means the same. This is the benzene. Okay. Now if I want to put if I want to connect any halogen, okay, where should I connect it? On the carbon. On which carbon should I connect? Benzene is also written in this way. This is because these double bonds keep moving. So what I do, instead of drawing the individual double bonds, I just make a circle to represent that they are moving, and that is called resonance. So you can see either this structure, this type of structure, which is a detailed structure with C carbon and hydrogen, all carbon and hydrogen shown, or you can have this kind of structure, right? So I was asking Zainab and Jasleen, Ibrahim, that where should I put the halogen? How many different places I can put halogen on benzene?
Six different places.
6 different places. Yes, there are 6 different places available for me.
But we'll have to remove a double bond. I think. Yeah, we'll have to.
No,
remove
you can
double-
keep the double bond. You have to remove.
Oh yeah, we can keep the double bond. We'll have to remove a hydrogen.
Yeah, you substitute hydrogen.
Yeah.
Zainab and Jasleen, would you like to add anything more? There are 6 carbon, that what Ibrahim said very correctly. Yes. Anything? So are we getting 6 different places, or all 6 places are same? Just think in this.
Sir, could you explain it again? I didn't understand.
Now this structure is clear of benzene.
Yes, sir.
You can see the benzene in 3 different forms. It is all one and the same thing. Okay, this is a different way of writing benzene. I am asking you that where should I put the halogen, on which position, and how many different places I can bring the halogen such that I can get a new compound, a different. And Ibrahim said very correctly that there are 6 carbon atoms where I can put the halogen. But Jasleen and Zainab, tell me, are the 6 carbon atom of the different type? Should I consider them one by one, or are they all of the same type?
They are all the same.
Yeah, they are all of the same type. Why? Jasleen and Ibrahim, why they are of the same type?
So because every carbon has a hydrogen, a single bond, and a double bond attached.
Yeah,
It's
actually, yes, exactly. It is a regular hexagon.
Yeah.
You can just choose any of the carbonate hardly from,
Yeah.
and don't bother about the numbering. Whichever carbon you choose to put the halogen, numbering will start from that carbon. That you will call it as 1. Okay. So if I put Cl, this is an example of, I hope everybody can see this.
Yes, sir.
This is an example of chlorobenzene.
Yes, sir.
Okay. Chlorobenzene. You can write the name. This is also an example of aromatic halide. where the halogen atom is connected not to an alkane but to the benzene ring. Is that clear?
Yes.
Zainab and Ibrahim, is that clear to you?
Yes.
Okay, great. So similarly, there are examples like this is fluorobenzene, or I can mention it like this. This is the phenyl ring. So this phenyl ring or the benzene ring is abbreviated like this, PHCl. Got it?
Yes, sir.
So don't worry that what it is. It is that same compound. Okay. If I put 2 chlorine atoms on the benzene, how many different options I can get? If I put then up 2 different chlorine atoms, there are 6 positions. One I can put anywhere. It is one and the same thing. But if I put 2 chlorine, at how many places I can put? So let's try to draw them by replacing. Of course, I have to replace 2 hydrogens. Okay, I can't put chlorine without removing hydrogen. So I have put them everywhere, all the possibilities. Okay, but I can't put it like this. Can I do it like this?
No.
No.
No, we can't.
No.
No, why? What's wrong with it?
No, sir, because here the carbon, the top carbon, it will be attached to 5, so it will be unstable.
Yeah, 5 bonds. 5 bond means carbon cannot make 5 bonds. Okay.
Yeah,
Yes.
it cannot. Yeah.
Exactly. Zainab and Jasleen, is that clear?
Yes, sir.
Yes.
Jasleen, is that clear?
Yes, sir.
Okay. So now I have written these 5 options. So how many are different and how many are same? That you can tell me. How many are same and how will you number them? That is also very easy. All 3 of you can do. This is, I will start numbering from this side and 1, 2, 3, 4, okay, 5, 6, right. So that is 1,2 dichlorobenzene. Got it? I'm not writing the complete name, 1,2 dichloro. Zainab, it is 1 and what should I write?
1,3.
1, 3. 1, 3 dichloro. Ibrahim, what should I write?
Sir, 1,4 dichlorobenzene.
1, 4 dichlorobenzene. So,
Yes.
and what about this one? 1, 2, 3, 4, 5, 6. Am I doing it in the right way?
No, sir.
No.
I'm not doing it in a right way because I'm choosing a longer path. Okay, this is 1, 3 only. Got it? This is same as that of 1, 3. Because I will do the numbering in this way, 1, 2, and 3. So from wherever you have an atom nearer, you will move that side. So don't follow a long way to do the numbering, longer path to do the numbering. And this is also 1, not 1, 6. This is 1, 2 only. Is that clear? So it is not a new compound, it is same as that of 1,2. So Zainab and Jasleen, can you tell me how many dichloro derivatives benzene can have?
3.
3. Yes, this is an integer type question which you can get. Okay, or options. What is the common name for this? What are the common names for 1, 2, 1, 3, and 1, 4?
Ortho, para, and meta, yeah, I think.
Yes. Okay, just a second. So 1, 2. If you have two same atoms or two atoms on the benzene, this is only for benzene, not for cyclohexane. This is only for benzene. This is for ortho. Dichloro. Benzene. If you have on alternate positions 1 and 3, that is called meta. Got it? It is represented by M. This is represented by O. And this is para. Short. Para dichlorobenzene. If you put 2 chlorine, then you have this kind of approach. Is that clear or not? Ibrahim, Zainab, Jasleen,
Yes, sir.
clear?
Yes.
Okay. So now we can start the preparation of alkyl halide. Just we started with the introduction. How do you prepare? How do you prepare alkyl halides? What's the method? From alkane. If I give you alkane, suppose if I give you methane, and if I ask you to convert it into chloromethane, what you are going to do? Any idea?
Sir, Markov addition, I think, yeah.
Yeah, that is for
Plus
alkane.
H.
That is for double bond.
Yeah, that's for double bond. Okay.
That is for double bond. Yeah, that is also one of the method. We will come to that. From alkanes, actually, as I told you, that we will cut off one hydrogen, and we will, in place of that hydrogen, we are going to put chlorine, bromine, or iodine, whatever is being asked in the question. So what I will do, if I want to prepare chloro derivative, I'm going to take Cl2. Definitely, I should heat it with Cl2. Got it? Jasleen, is that clear?
Yes, sir.
But on its own, the reaction is not going to start. That you also know, I also know. We need to provide some energy. So Zainab, Jasleen, Ibrahim, how am I going to give that energy for them to start doing the reaction?
Heat.
Heat and
Catalyst, palladium.
or
Palladium.
heat, or you can use light. Light is more specifically UV light. UV light is carrying more energy, and it can break the bonds. Sometimes they write it like this also, sunlight. Got it? Is that clear?
Yes, sir.
Because you need to break the bond. Either you can heat, that is called breaking of bond, carrying out the reaction by heat, okay, or light, because it is easier for us to give the light, okay, UV light or sunlight. If you keep the reaction mixture in sunlight, that has some UV light component which is more energetic, and that can be helpful in breaking the bonds and carrying out the reaction. Because of this reaction is also known as photo halogenation. So what's the full form of photo and halogenation? Why this name?
Addition of halogen in the presence of sunlight.
Yes, photon. Sometimes it is also written like this, H nu, which represent the energy of a photon. You must have studied in class 11, but don't worry if you forget. We will revise all the things, okay? So what happens here is you are providing energy, and what you need to do, that is very simple. This is the shortcut to carry out the reaction. You remove HCl, you break H and you Cl, then what happened to these two bonds? They will connect. Got it?
Yes, sir.
Remove HCl and connect them together. So this is how the haloalkenes are prepared. So how haloalkenes are prepared? From alkanes. What is the method? What you are going to say? You are just going to say by photohalogens. By mixing the halogen and Cl2 in the presence of light. Suppose if I react it again with Cl2, that can also happen. CH3Cl, if I take 2 moles of chlorine, then the reaction can happen again. Got it? What am I going to get? If I react it again, Jaslin and Zainab, tell me.
Like Cl.
One Cl has already come in place of hydrogen. What happens if I react the CH3Cl with chlorine one more time? Got it?
Sir, again it will replace, yeah? Again chlorine
Yeah,
will
again it will replace, so
hydrogen.
it becomes CH2Cl2
CH2Cl, yeah.
and HCl.
Yes.
Got it? This is known as dichloro, 1,1 dichloro. Sometimes one is there, there's no need to write it because you have just one carbon. Methane. And if I take 3 moles of chlorine, what is going to happen? This CH2Cl2, 3 mole, the third mole will react again. Got it? What you are going to get? CHCl3 and HCl. Is that clear?
Yes, sir.
What is the name of this compound? The same approach you can follow. What is the name of this compound? There are 3 chlorine.
Hydrogen.
1,1,1 trichloromethane. Exactly, Jesslyn. Very good. So Jesslyn has already told me the answer. Zainab and Ibrahim, you can tell me what is the common name and where it is used.
Chloroform.
Yeah, chloroform.
Yes, sir. Chloroform. Old anesthetic it was.
Yeah, where it was used earlier.
It was as an anesthetic, I guess.
Yes, anesthetic.
Yeah.
Yeah, very good. Chloroform. So now you know how to prepare chloroform. Just take 1 mole of methane and carry out its chlorination 3 times by taking 3 mole of Cl2. You will get a chloroform. And if you take an excess of chlorine, means 4 moles or more than that, so what is going to happen? The reaction may happen again. Got it? It may happen again. And what you are going to get? Ultimately, this will be the final product for methane. It is going to be CCl4, carbon tetrachloride. It is also known as pyrene, common name, and it is used as a fire extinguisher. It is given in NCERT. I hope this is clear.
Yes, sir.
All of
Yes.
you, that how you carry out chlorination one by one, Zainab, Jesslyn, Ibrahim, okay? And accordingly, you can get monochloro derivative, dichloro derivative, trichloro derivative, or tetrachloro derivative in case of methane. Okay, you can have more chloro derivatives. Okay, more chloro if for higher alkanes where you have more number of hydrogens to be replaced. This is quite clear. Okay. And suppose there is a compound pentane. What's the formula for pentane? It has 5 carbon atoms.
Yes, sir. C5H12.
Yeah, and hydrogen will be twice the number, 2 more than twice the number of,
CmH2n plus 2. Yeah.
2n plus 2. So this is pentane, and n equal to 5, so C5H12. Okay, C5H12 is there. So it has 3 structures, 3 isomers. What do you mean by isomers?
Same physical property, different chemical.
Yeah, that come later on. So first thing you need to say is that they have same formula but different structure, because there are 5 carbon atoms, so you can connect them in different ways. Got it? The same formula but different structures. Okay, so pentane, are you comfortable with this kind of terminology, what this is known as?
Bond line formula.
Bond line formula. So instead of writing carbon and hydrogen or carbon atoms, I don't represent carbon. This is carbon, this is carbon, this is carbon, this is carbon, this is carbon. Okay, this is known as bond line. Only the carbon bonds are shown. No carbon, no carbon atoms and no hydrogen atoms are shown. Okay, but we need to check on our own. For example, at this carbon there should be 1 hydrogen, because each carbon can make 4 bonds only maximum. So 3 lines you are already seeing. So which is the 4th atom? 4th atom which is not mentioned, it is obvious that it is hydrogen. Okay, normally we do not write it. Is that clear to everyone?
Yes, sir.
So this is the bond line representation. Very quick to write, very easy to write, very comfortable. We can write in a very short time. So all have 5 carbon atoms, just you can check. Okay. So, and this is normal pentane. This is the common name. This is 1, 2. I will do the numbering from this side because this is giving the lower number 2. I should not come from the left hand side because that is giving the number 3 to that branched position. So this is 2 methyl. So 2 methyl, that is the IUPAC name, and this is iso pentane, and this is neopentane. Got it? Normal pentane means it doesn't have any branch coming out. All the 4 carbon are one after another. Iso means there is a branch of 1 methyl coming out, and rest of the carbon atom, total carbon atom will be 5. So 1 carbon is coming out from the out of the main carbon sequence. This methyl you can see. And neo means 2 carbon atoms are coming out of the 2 carbon atom coming out from the main chain. That is neo. IUPAC names are pentane, 2 methyl pentane, and this is 2 dimethyl pentane, because I will do the numbering like this. I hope this is clear to all 3 of you.
Yes, sir. Yes.
These are the isomers of pentane. They are having same formula but different structures, due to which their physical properties are different. Their boiling points are different. Got it?
Yes, sir.
So now my question is, if I do the chlorination with 1 mole, if I do the chlorination with 1 mole, this is the short way to write. Cl2 dash H nu means light. Okay. How many different monochloro derivatives I can get? You need to draw them. How many monochloro derivatives for pentane?
5.
There are 5 carbon atoms. But are all 5 of them unique? That you need to check. If they are unique, I will put the Cl on each one of them and I will get a new compound. Got it? So this is 1. What you can do is 1, 2, 3. You can do the numbering. And if I do the numbering from this side, now you can tell me how many different carbon atoms are there? Which are totally different.
3.
This one, yeah, 3 will be 3 different carbon atoms, because 1 and 5 are same. Look, because if you do the numbering from that side, that 5 will become 1. If you do from this side, this 1 will become 5. Okay. And 2 and 4 are same. Got it? And Ibrahim, this 3. Is that clear or not?
Yes, sir. Yes, sir. Clear. Clear.
So if I want to put, though there were 5 carbon atoms, but because this side and this side come out to be same, because it was symmetrical if you flip the molecule like this. So How many different chloro derivative you will have? Now tell me. Zainab, Jasleen, tell me quickly.
3 different chloro derivatives.
How many?
3.
Yeah, 3. Zainab, how many as per you?
Sir, 3, sir. Yeah, 3, exactly.
Yes, 1 chloro,
1 chloro, 3 chloro.
2 chloro. Yeah, we can
Yeah,
proceed
2 chloro,
one by one, and 3 chloro.
3 chloro, yeah.
Got it? 1, 2, and I hope this is clear. Got it. Why not 4? Because 4 and 2 will be same. Why not 5? 5 chloro, because 5 and because if it is on 5, you will start the numbering from that side to give it 1. Okay. So 3 monochloride derivative. This is the question from an NCERT in-text problems. Okay. So I hope this is clear. Look, this is the problem. This is the basic class. This is the basic theory from your NCERT only. Okay. This is the classification on the basis of numbers: mono haloalkane, dihaloalkane, trihaloalkane. Got it? A classification on the basis of type of halide: chloroalkane, bromoalkane, iodoalkane. Classification on the basis of type of carbon atom: primary, secondary, tertiary. We have seen primary connected to 1 carbon, secondary connected to 2 carbon. What is this R? Can you tell me what this R is?
It's a
Functional.
carbon group.
Yeah, carbon group. Just like that in algebra, Zener, what we say that let the number be X. Okay. In organic chemistry, whether it is methyl, ethyl, propyl, okay, general way of saying it is let it be R. Got it? Is that clear to everyone?
Yes, sir.
Yes,
So secondary means it is connected to carbon connected to 2 alkyl groups. Tertiary means carbon connected to 3 alkyl groups. Okay. Allylic and benzylic. Allylic is actually next to double bond. Next to doubly bonded. This is doubly bonded carbon atom next to it. That is allylic. This is also allylic next to doubly bonded carbon atom. But this is not benzene. Okay. And then you have benzylic. Benzylic is next to the carbon atom. This is aryl. That we have seen. Okay. This is aryl. And benzylic is the carbon atom next to benzene. That is benzylic. We have seen aryl halides which are directly linked. If there is a carbon outside and the halogen is connected to carbon next to benzene, that is benzylic. Is that clear? So both of these are benzylic halides. Okay. So we have seen this classification and just read it. We are doing the nomenclature along this. We did all the questions, most of them, and we are still doing a lot of. Just go through the common names. So you have to today after my today's class, you have to complete up to this point. Are you getting my point? Zainab and Jesslyn. Okay. So you should be comfortable up to this point. Got it?
Yes.
Clear? We will come to that also. Just I will once we get into the physical properties, we will start the nature of. We need to wait for this. Okay. So I'm putting a star. We need to wait here. Okay. We will be doing it afterwards. But we started with the preparation. Okay, method of preparation of haloalkenes. So we are coming to that from which we started from hydrocarbon. So by free radical halogenation we did. Okay, by photohalogenation you take light, sunlight. Okay, and this is what we are doing right now. And we are doing this type of question, these types of questions. Okay, so we are doing these types of questions. Currently, I think we are. This is a famous question. And in text forming this one, we are doing this question 6.4. I hope it is clear to you what we are doing right now. Okay,
Yes, sir.
so just we are trying to draw that because this is a very important example. It is so important that it was asked in JEE Mains Advanced many times. It is so important. It is given in the NCERT, but still many people they were not able to answer it correctly. Okay, so NCERT contain a lot of information. Okay, and it has been asked in CBSE also. So this you answered very correctly. And let's try for the neopentane. How many monochloro derivatives you can get? How many monochloro derivatives you can get for neopentane?
Four.
You have 5 carbon atoms, Jesslyn. Okay, and Zainab, one of the carbon doesn't have any hydrogen. Can you tell me which carbon doesn't have any hydrogen? Yeah, Ibrahim?
Sir, the central one. So I'm guessing only one, yeah? Basically one monochloro derivative, I think.
Yes, exactly one. Because all 4, it is just like a cross, symmetrical cross. Okay.
I know, yeah.
So
From any plane, it's symmetrical. From any
yeah,
plane.
it is symmetric. Zainab, are you getting?
So could you explain it again?
Yeah. So how I'm asking, is this carbon different from this one and this one and this one, or are they all the same?
They are same.
They are same. So should I, while putting the chlorine, should I consider them separate and I put chlorine one by one to get different products, or all the products will be same?
All the products will be same.
All the products are going to be same. Okay, because if I put it like this, or if I put it like this, if I put it like this, okay, somebody may call that they are different. They will have different names, but will they have different names? Yes or no? Or will they have same names? Same IUPAC name, because I am going to start the numbering from the carbon atom containing Cl1, 2 and 3. So this is 1-chloro-2,2-dimethyl propane. Here I am doing, we'll do the numbering from this 1, 2 and 3. 1-chloro-2,2-dimethyl propane. 1, 2 and 3. 1-chloro-2,2-dimethyl propane. Are you getting my point? So they are all one. Though it may appear that one in one the Cl is another it is down, another molecule it is on the right hand side, in the fourth one it is on the left hand side. But as I told you, this right left doesn't matter. Okay, is that clear to you? Zainab, Jasleen,
Yes, sir.
Ibrahim, just one. Okay, so N-pentane, normal pentane, or just pentane will give three monochloride derivatives. Isopentane, neopentane will give just one monochloride derivative. Okay, and what about the isopentane? How many monochloride derivatives isopentane is going to give? This is bit longer. So you can try this one. Zainab, are you getting me?
Yes, sir.
Okay, so how many different carbon atoms are there on this? Just we need to figure out. So from where should I do the numbering? One
Right side.
or one? Right hand side or left hand side?
Right.
From where?
No, sir. The other side.
Okay, we can do this from this side. Because the methyl is closer. 1, 2, 3, 4. Or you can do it like this also. 1, 2. This both are one. They are both methyl connected to the same carbon. So it doesn't matter whether you start doing the numbering from this carbon or from this carbon. Got it?
Yes.
Yes, sir.
They are both methyl, interchangeable. They are both connected to the same carbon. It is not that one methyl is green colored, another one is red colored. No. Ibrahim, are you getting my point?
Yes, sir. Yes, sir.
So they are both same. So we can take any one of them to put, we can choose any one of them. If they are same, we should not consider them again and again. Okay, that's what my point is. So I can put the bromine here or Cl if I'm doing. I can put the Cl on this carbon atom. There is one hydrogen on the second carbon. I can put it on the third carbon atom. And I can put it on the fourth carbon. Okay. Is that clear?
Yes, sir.
So I'm going to get 4 different monochloride derivatives. Got it?
Yes, sir.
So there is pentane. Pentane can, so how many monochloride derivative pentane can give? You need to know which pentane you are talking about. If I'm talking about just pentane, which is without any branching, 3. If it has one methyl group connected, then it will have 4 monochloride derivative. And if it is neopentane, it is just 1. So this is 1 monochloride derivative. Okay. This is having 3 monochloride derivatives. And this is having 4 monochloride derivative. I hope this is clear to all of you. Just
Yes, sir.
let me know if there is any doubt. Jasleen, Zainab, Ibrahim.
No, sir.
Great. Clear?
Yes.
Yes.
Okay, good. So this is the question which we discussed just now. Okay. And you can try these problems one by one also. And we did the preparation from alkane, that is by photohalogenation. Okay, photohalogenation means you are carrying out the halogenation. This is the question which we did just now. Okay, photohalogenation means you are carrying out the halogenation in the presence of light or UV light or sunlight. Okay, and you are actually for methane actually just one place where you can put the Cl. Okay, But for larger alkanes with more number of carbon atom, you have more places where you can put in the Cl atom, one Cl atom. So even if you put one Cl atom, you can have different monochloro derivatives you can get. Okay. So this is preparation from hydrocarbon, and what Ibrahim was telling at the starting, that was the preparation from alkenes. Got it? So let's do this. Okay. So after alkanes, we have alkanes. After alkanes, we have alkanes. So preparation of alkyl halides from alkenes. How from alkenes? By carrying out addition of HX. Okay, just like in the mathematics, we are having addition. In organic chemistry, we are also having addition reaction. And their name communicates a lot of things. Addition means two atoms are being added to the double bond. Okay. So what you do, you take an alkene. This is the smallest alkene. What's the name of the smallest alkene? Zainab, Jaslin, Ibrahim, just tell me quickly.
I'm sorry, sir. Come again.
What is the name of the smallest alkene?
Ethene.
Yeah, ethene.
Ethene. Yeah,
Ethene.
double.
Okay. So there is a double
Yeah.
bond. And you know the double bond, the second bond is weaker. Okay.
Yeah.
And you can take some HX. For example, you can take HCl or HBr or HI. They are acids.
Yeah.
Okay. So they will already have H plus and Cl minus separated. So then where do these H plus and Cl minus go?
For the hydrogen.
Yeah, they will get added. They will get added onto the double bond will break. You break this bond. If you break this bond, you will worry that what will happen to the bonds. You will put, on one atom you will put H, another atom you will put Cl. Okay. Is that clear or not? So this is what this reaction is known as addition of HX.
Markovnikov.
Yeah, that we are coming to that. Got it?
Yes.
Addition of HX. Addition of HBr, you are going to get bromoethane. If it is actually unsymmetrical, then you need to bother. For this one, you don't need to bother. That where am I going to put the H? Where am I going to put the Cl? You can put them the way in which you like, because both sides it is same. Both sides are same. It is very small alkene, just two carbon atom. You don't have options. On one you can put the chlorine, and another you can put the hydrogen. Is that clear or not?
Yes,
Yes.
sir.
Now the question arises when you are asked to add CH double unsymmetrical alkene. This is an example of unsymmetrical alkene. Got it? So in this, you can see that unsymmetrical alkene is there, and now it is a matter of concern for me that where should I put H and Cl. Are you getting my point?
Yes.
Because now I have two options. What are those two options? Or HBr I can take. It is same HBr, HCl, or HI also you can take. So Ibrahim, tell me which option should I choose as my answer?
The Markovnikov states that the negative with the least hydrogens. So the first one, left one, CH3, CH, Br, CH2.
Yeah, what it says?
The negative part of the addendum gets added to the carbon atom to the carbon atom of the double bond with the least amount of hydrogen. That's what it says, yeah.
Markovnikov or Markonikov. Okay, you have different spelling as it is a Russian name, so don't bother about the spellings. Okay, Markovnikov rule. It says, if I say it in terms of H, for H atom, you are going to follow Markovnikov rule, and rich gets richer. Means this is with respect to H atom. Jaslin, Zainab, Ibrahim, what it means with respect to H atom and what this statement rich gets richer means.
Rich gets richer means the one who has more gets even more, yeah.
Yeah, the H atom will attach to the carbon atom bearing more hydrogen.
With the most, with the least hydrogen.
H atom.
No, with the most hydrogen,
Yeah, for H atom it is rich gets richer. Okay.
Yeah.
If I say, so where the H atom is going to get attached to the carbon atom
With the
where you
most
already have more number of hydrogens. Got it? Jaslin, Zainab, are you getting my point? This is a mnemonic to learn how to put H. Are you getting my point?
Yes, sir.
Rich gets richer. So wherever you have more hydrogens, put hydrogen on that atom. Choose that atom to put hydrogen. Okay. And where to put Br?
with the least part, poor gets poorer.
Yeah, put the negative atom on the carbon atom bearing less number of hydrogens. I hope you are getting my point.
Yes, sir.
So this is called Markovnikov rule. Okay. And under certain circumstances, so this we are not going to get. It can happen only in certain circumstances. So this is going to be the major product.
This is with peroxide, yeah, the second one.
Yeah,
In the
that is the
presence of
minor.
peroxide.
That is the normally if you add HBr without peroxide, this is the minor.
Yeah.
Minor doesn't mean juvenile. Got it? It means it is formed in less amount. Is that clear, Zainab and Jaslin?
Yes, sir.
So without, just if you add HX, HBr, which gets rich, that you need to follow. So just that can happen, that minor product will become major in under circumstances in presence of peroxide, that I will tell you. Okay. So first we can practice Markovnikov rule. So what I will do, I will give you certain examples and you need to tell me what is the product. Okay. There are two carbon atoms, one carrying more number of hydrogens. You are going to put the hydrogen atom on that carbon atom only which has more number of hydrogens. I hope this is clear to you. Are you getting my point?
Yes, sir.
So I will write both the options. You need to tell me which product is the main answer, the right one or the left one. I will write two options. Okay. So double bond is outside the ring. I break this double bond. I put Cl and H. Or if I write Cl and H, that H you don't need to mention. Sometimes it is not written because in bond line the H atoms are not shown. Are you getting my point? So I have written two products, Zainab, the right one and the left one. By breaking the double bond and putting H and Cl either in this way or in this way. Got it? So either I put in this way or this way, okay, by choosing the two carbon atoms. In the second option also I can write it, do it in this way. So first of all, tell me, are the products clear? Whatever I am writing.
Yes, sir.
So CH3, CH2, I can put I and H here. And Ibrahim, I can CH3, I can put I in the middle and H towards the end. These are the two options, or I can just put it in this way also, so that you can clearly distinguish. Similarly, this is phenyl, which is the benzene ring. Is a short form to write the benzene by short form of its name, phenyl. So I will write it benzene. I can write phenyl or I can write the benzene as a whole. CH2. I can put H and Br. I can put H and Br. Got it? For this, I am writing it here. There's a double bond and there is a methyl. This is the methyl. Okay. I need to break this double bond. So if I break this double bond, I need these. I need to put the two atoms, hydrogen and iodine, on these two carbon atoms. So I put the hydrogen here and the iodine here. Or I put vice versa. I put iodine in the middle and hydrogen on the bottom corner. Is that clear? The options I
Yes.
have written. So you need to tell me, Ibrahim, you tell me which is the main product for the first one.
For the first one.
Right one or the left molecule, which is the major product. Which is the main product.
Just a second, huh?
This is CH2.
Okay. The CH2 attached, no?
Because I have not written means it is bond line on some, so it is obvious that it is CH2.
Okay. So the hydrogen, it will go to the CH2 atom. Yeah, okay. There's that. So it has to be the second one. The second one, I think.
The right one.
Yeah, the right one. Is it?
That.
Yeah. I think so.
Yes. Because
It is.
this is minor product because you are attaching hydrogen in the middle to the carbon atom. It doesn't have any hydrogen. Getting my point or not?
Yes. Yes.
The middle carbon doesn't have any hydrogen.
Yes.
Zainab and Jaslyn, is this first part clear to you?
Yes, sir.
In case of any doubt, don't hesitate to stop me any number of times. Okay? Don't worry. Zainab, is it clear?
Yes, sir.
Yeah. Okay. This one, are you Jaslyn? Okay, last one. Are you asking Jaslyn this one?
Yes, sir.
Yeah. I'm coming to all of them one by one. So second one, I have written the possibilities. You need to tell me. Second one, Zainab, you can try. Second one for this molecule. I put H and I like this and this. Okay. On the double bond. Can you tell me which one is the major product, A or B? Which is the major product?
B.
B is the major product. Yes. Is that clear? Why? B, you have made B anything. You can add, you are correct. This is the main product which you are getting. Yes, Zainab, can you tell me? Major means it is formed in large amount. Got it?
Yes, sir.
Yeah, is that clear? Because you are going to put H on the atom where you have more hydrogen, two hydrogen, and in the middle carbon you don't have any hydrogen, so you are going to put the I, which gets richer. Okay. And Jasmine, what about the third one?
So the
You have
first
these two.
point.
The first one, yes, because you are having 2 hydrogen, I am going to put the hydrogen on the carbon atom bearing more number of hydrogen. Yes, this is the main product, major product, which we are going to get. This is the major. So Ibrahim and Zainab, is that clear? The third question.
Yes.
Zainab, is it clear or not? Tell me.
Yes.
And now we come to the fourth option. So all 3 of you gave the right answer. I will explain the fourth option. Okay. So fourth option, if you look more closely, it is like this. There is a carbon, double bond carbon, and there is a methyl group attached. Do you agree with it? This is the methyl. And there is hydrogen being attached to this because this carbon is having 3 bonds, one double bond, one single. So where is the fourth atom? Fourth atom is not mentioned, that is hydrogen. Got it? Is that clear?
Yes, sir.
So now, as per Markovnikov rule, what should I do? Where should I put H? Rich gets richer. Zainab, so where should I put H? On the top carbon or on the bottom one?
On the bottom.
Yes, bottom one, because you have already 1 hydrogen, so you are going to put the hydrogen on the carbon atom, Ibrahim, where you have already have more hydrogens. Okay.
Yes, sir. Yes.
So this is going to be the answer. Okay. This is going to be the answer. So I hope this is clear. Major product is governed. This is known as addition of HBr, HX, addition of HI on alkenes. So today we discuss the general naming, nomenclature, preparation of alkyl halide but from alkanes by reacting them with halogens in the presence of sunlight. Okay. And we also, by that, we also try to understand that how many different alkyl halides can form. That question arises when you have more carbon atom on bigger alkanes. Okay, where you can put the halogen. Okay, that's the question. Okay, clear? I hope
Yes.
this is clear to
Yes.
you. Okay. So next is anti-mark when this minor product is formed. Okay. So that we can discuss in the next class. I will give you some assignment questions from your NCRT only. Just do them and just read it. Let me know if there is any doubt. We will continue it on the next. So bye everyone. Everybody responded very well. So thanks for that. Keep doing like this. Okay. Bye everyone. Good night. Take care.
Thank you, sir. Bye, sir.
Okay, thank you, sir.